Hi there, Andrew Jackson, AJ Design Studio. I've been looking through my Solidworks example and tutorials folder and remembered something I created about a year and a bit ago, which was using a sketched graph setup to control like a variable pitch pattern. Those videos are online, I'll stick links in the description in this video, but I thought I'd do some further work with that because there's potential to do lots of things with using a sketch as a graph to control spacing. So I'm just going to roll back through. I've got a couple examples. I've got this one here and this one over here. So I'm just going to roll back to the beginning here and explain how the graph setup works. So the idea being that if you've used Pro Engineer Creo Wildfire before, there's a graph feature in there, and you can have a graph in it, and it samples from 0 to 1. And anything you draw in, you can control dimensions or whatever, pattern pitch, using the result out of that graph. So in SolidWorks, to replicate that, I've made a pitch control graph with a nominal 100 mils across here. This could be any value, but I've made it 100 by 100. And then you have your graph, so depending on the slope of this graph, that changes the pitch of my pattern, and I'll explain how that works. So I've created a pitch control, the spline, and added a line at the beginning and end just to get some constant slope. So then the next feature after that is I've fitted that together into a spline. If you didn't have the line at the beginning and the end, if this was just a spline right down, then you wouldn't need to fit that into a single spline. Okay, next thing I've got is something called a deform curve, which is basically just 100mm line from point to point across the X on the graph. And then I've created a thing called a tool surface, which is a planar surface, like so. So I've just drawn a rectangle, given it a dimension 1mm, and made a planar face. Okay, next up is I've created something called a tool profile, which in this case is a wedge that comes down to 0 on this end. So that angle could be anything, just because when I make a series, I make my pattern across here, I need to make it into a single solid, so I can then use that single solid with lots of these wedges on it to split. You insert split lines across this tool surface in one go. It will all become obvious in a sec. Plane's just the top there, the top of that wedge, and I've made a tool body, which is again just a rectangle, so converted entities of the tool surface, and then made a boss extrude. It doesn't matter about the height. And then I've made an extrude, which is the tool, and it's quite important that the tool is longer than the Y of the graph, because I'm going to pattern this wedge along this curve here, like so. And you can see, it's all very obvious now, depending on the slope of the spline, you get variable pitch across the X, because we're projecting downwards. Okay, and the reason why that's a solid and then this is a solid is so we end up with one solid body here, which I can then split this surface in one operation, as you can see there. So selections is the pattern tool, and I'm splitting that planar face I made, and as you can see there, it's split it into several pieces. So the good thing about this setup at the moment, well, you can get about halfway through it. The pattern, you can control the pattern and you can change the instance count, and the split will update this tool here. I'm still working out how I can get the rest of the geometry to update once we take this data and then apply it onto a surface. So I'm not going to touch the instance count at the moment, and it's an odd number because I'm working on some ripples, making a textured ripple across the surface. Okay, so I'm just going to leave like that as it is. And you can see also why this tool body has to be longer than the Y axis is, so it overlaps. Okay, so I'm going to hide the tool body. So The idea is I take this tool surface, which is split into variable length sections, and then that gets deformed onto the geometry where I'm actually going to create the ripples. So the next thing I've done is I've created when you use the deform tool and use curve to curve, you need like a base curve and a target curve. So this is my base curve, which is just along one edge of the tool there. It's just a line coincident to each end. And now I'm going to make a sweep. As you can see, I've got a boundary rectangle and then a sweep section and a sweep path, and I've just created a domed surface. Okay, and on that domed surface, hang on, I'm just going to change the make things a bit brighter. Okay, on this domed surface, I'm going to chop out a section and create some ripples. So to chop out a section, for this first example, I'm going to use face curves, which are basically, they're like ISO curves if you've used Rhino. So if you insert a 3D sketch, and then if you go Tools, Sketch Tools, Face Curves, and you pick a surface, you get to pick whether you want a mesh or a position, and you can extract a curve in one direction or the other. So what I've done here is I've extracted 4 curves. This one's 80% on the face, this one's 20. You can change these numbers afterwards as well, but unfortunately you can't link this to an equation or anything outside of the 3D sketch. And then one over there, and then I have converted those entities into a 2D sketch, made a surface extrude, and then I've split this face into 2 bits using the split tool. So if I go back up here and show the other half. So if you haven't used the split tool before with a surface, what you can do is you go, and so instead of, before the split tool was there, you'd make 2 copies of this and trim it twice. Trim it once and keep the outside, trim it the second time, keep the inside. But now, for a while, you've been able to go insert, feature, split, and you pick your trim tool, which is the extruded rectangle, and then target bodies is the sweep, and you cut the bodies and you can keep both resulting parts. So now I have 2 separate bodies there. I'll just delete that split because it's not needed. I've got this one here. Okay, I've got a body move copy here because I've copied my pattern tool, copied my variable pitch, and now I'm going to deform that to match both one end of the surface. Now if you haven't done this before, I'll just run through it quickly. So insert, features, deform, curve to curve, so you want to pick a base curve. So in this case, it's that one there, and then the target curve, which is the end of the surface there. Oh, sorry. Got to swap into the target box before you pick it. Okay, and then I want, the ends aren't lining up in the same direction, so I want to come over here and click on here. So this corner will line up with this corner, and then you pick a body, which is our little ribbon there, which is chopped into segments. Okay, so now it might look, not flash in the middle, there might be some distortions on the surface, but the main thing is that these points here, the segments actually line up on that edge, which is all we need. We just need those points. I'll just delete this deform because I've just used the one I've already set up. Now I'm going to create a 3D sketch. Because we've got ripples, I'm basically going to go up, down, up, down, up, down. So I'm going to pick every second segment on my tool body there, and they're going to lie on this surface. So in this case, because I've decided I was going to use face curves, each of these curves is a face curve that is coincident to a point here. Unfortunately, I'm not sure why Solidworks pops up with a question mark when you do this. I'll just show you how to do it. Insert, sketch tool, face curves. We'll pick that, the swept face, and we want to pick in the pink direction, so we turn blue off, and then we go position, and you have a opportunity here to specify a position vertex. So I'm going to pick that vertex there, and if we change the pitch of the pattern here, this 3D face curve will update, even though it's got a question mark there, so unsure why that is. So I've done that with every second curve on that face. I'll go OK, and now I've created a second surface, which is sort of like, so this is the trough surface. I'm going to create a surface that's above the main swept surface, which is like the peaks of the ripple. And I've done that by making a sketch. I've offset the centre of my swept trim surface there, so 0.5 up. And then I've created a boundary surface just by picking the edge, the end edge of the trimmed or the split sweep, that new sketch in the middle, which is 0.5 up, and then the other end of that split swept surface, and then made them tangent. So at this end it runs down to being tangent. Okay, and now I've just repeated this face curve thing, except I've done that with the new target surface. I've picked the new surface, like the peak surface. So you can see these curves are above these ones. And I've picked every second one again. It's stepped. My step is, I'm stepped out by one. So again, you know, insert face curves, pick surface. In this case I want to keep a blue one, so turn the pink direction off, UV direction, and then pick a position, and then instead of using a length ratio, I'm going to pick a vertex, like so. Okay, so I just repeated that across. Okay, so now I'll hide these surfaces. Next up is I've created a loft through all of those curves in the 3D sketch that we created. Okay, so you can see there's lots of curves, and because those 3D curves are all in two sketches, you have to use the selection manager. I'll show you what I mean. So if I go alpha loft, see it's popped up with the selection manager because it knows that's an entity within a 3D sketch which also has all these other curves. So if you just push enter, if you pick one and then push enter, you can move on to the next one. Whoops. And so on, and that's how I built the loft there. I'll go into the actual loft I made and just show you, because I set up a few boundary conditions. So if I show that loft, and I'll show the exterior section of the split surface, the surface that we split earlier. So the loft in this direction across with all the curves, the first and last section is the edge of the surface, and then I've added a tangent constraint to that edge and that edge. In the second direction, I didn't bother with guide curves. These seem to be falling within tolerance, so I didn't bother picking them, because if I select OK and then we go and knit that body together, you can see the outside, the tangent font means it's tangent, but if you run a deviation calculation on there, it's only 0.02 degrees out of tangent, so there you go. So that's what the variable pitch does. I can see one thing I want to change here. See how these ripples here are very harsh. They're the same height as the ones in the middle. You can see that they don't adjust their height to do with their pitch, or their wavelength. So what I can change is that top surface I made. We'll just go in quickly and change this offset from being an offset to make a pierce point relationship on each end, and then I can, on the centre line, just put a little construction line in there, and we'll dimension that. So now the ripples as they go down towards the edge will get smaller in height. There we go, as you can see. And now I'll show you what the flexibility of this variable pitch graph is. I'll just save up. Okay, so my pitch control, if I want to make the ripples on the outside smaller, I can make these sides steeper. Now this is symmetric at the moment. I can change this side independently from the other, so we'll have a look. So I just rebuilt, you can see what happened there. The ripple on the outside got smaller, and the pitch, the wavelength towards the middle got larger. And as I said, you can make this asymmetric. I'm unsure what the result will be, but let's have a look. Okay, so we've got longer waves over here, and then they run down to smaller ones over here. let's make that more extreme. 70. I just make these tangent lengths a bit shorter. Okay, so you can see what's happening there if I bring up my graph. In my graph body here, you can see a fairly even, consistent change in the dimension. As we go from left to right, they get larger, which is being reflected down here in the surface. Let's try something else. Let's try changing this dimension and see what happens. Okay, so that update's okay. Change the curvature of the sweep. And that update's okay. So it's quite a robust process. I mean, you know, there is a bit of mucking around having to make this graph first, and as I said, it'd be great if I can translate how many instances that are in this pattern here on the curve tool, on the curve pattern control, if I can update that so the sketches here, or the lines I have to pick, update as well. I haven't found a way to do that yet. Okay, so I finished this and I decided that's quite limiting using face curves on this, because it means I'm stuck to using face curves follow the shape of the underlying geometry. So what if this cut here, or the split you put on, wasn't following the ISO curves of that surface? So if you want to make something that was a different shape. So that's where version 2 came in. So as you can see there, the cutout or the split does not follow that shape. So therefore, if I use face curves, I'll show you what happens. They follow that underlying shape, so they're not going to follow this cutout, which is what I want it to do. So therefore, I had to come up with a different approach. So everything above this pattern example is the same. Again, I've just made a swept surface. Then I've created my split where I want the pattern to sort of exist within, and each end's independent, so you know, you can tweak it. And then I've split that surface and made some copies of the tool surface, because I think I need 3 on this one, because what I need to do is deform my tool, my variable pattern tool, to this end, and also to a cross curve in the middle. So that's what, so there I've deformed it to each end, and then I need to create a cross curve through the middle. And to do that, I've just on the front plane just made an intersection curve with the surface, so that will all update. So that's just an intersection curve, and then using that intersection curve, I've added that last deform tool. So as I said there, you can see the deform tool's all sort of wobbly, the surfaces, but the actual, where that vertex of the tool surface lies on that curve, it's coincident, which is all we need. Okay, so to create our curves this time, instead of using face curves, I've created a boundary surface which uses 3 sections, and each of them is using the selection manager, and I've gone along and I've picked each of these lines basically. So if I was to do it again, be boundary surface, right click, selection manager, and then I've just gone through and picked, so 5 there. I'll just do this quickly. Selection manager, 1, 2, 3, 4, 5. I'm only doing 5, I did the whole lot across, but just for this example. And then selection manager again, 1, 2, 3, 4, 5. Now if I went OK there, we'd just come out with one surface. So what you want is to turn merge tangent faces off, and then you get the lines. So Solidworks is just extrapolating or tweening between these segments. So if I go into this actual boundary surface, you can see I've got merge tangent faces off. Okay, next thing up is we're just going to convert the entities out of that boundary surface. So every second one is a peak, and the other alternate ones are troughs. So I've created a sketch in which I've gone through and picked every second one. There's the boundary surface, you can see I've just picked every second one. So these are the peaks. So you start one in because the edge is on our split surface, and then created the troughs. To get those curves on the 3D surface, what I've done is extrude surface. So in this case, those are the peaks, and then done the same with the troughs, and created a 3D sketch to get those curves in 3D space. So these are the peaks, as you can see, and they intersect here with my peak surface, which is built in a similar way to in the first example. So using the side boundaries of the split surface and then a cross curve across here to set the height above. So that's the peaks and that's the troughs underneath. And extrude 3D sketch. So these 3D sketches are just extrude those lines up, and then you go up here into your surface bodies and you pick all the extrudes and the other surface you want to intersect and insert, tools, sketch tools, intersection curve, and it does in one go, because you can't project those curves on because it wants them to be one continuous entity. Okay, and then I've created a loft in a similar way to I did in the first example. I won't go into detail on that one. So I'll bring up the split surface around the outside. I will just show you that the loft, in this case I did pick the ends as well. So edges, start with an edge and then we go peak, trough, all the way down to this one. Okay, and then knitted that together, and just so I can get a higher, see how the render mesh is kind of cruddy there. Solidworks likes doing that, even though if we go tools, options, image properties, image quality, we're up on high. Now it might update and be nice again. Yeah, there you go. But if I edit something, it will revert to being cruddy. So if you thicken a surface, it kind of forces it to hold it on the higher quality setting for some reason. Okay, so if I turn the edges off, yeah, so there you go. And again, this is fairly flexible, so if we want to change the shape of the split or the boundary of the pattern, I just have to go down here to the extrude that cuts it out and rebuild, and that updates. And what else can we do? The pitch of the pattern. Okay, the pitch control here. Make those ripples really smaller on the outsides. Like that. Change the shape of the sweep. Yeah, so it's quite a robust technique. You know, this is just one example of an application of something like this, but having a variable pitch pattern and being able to control it in an easily understandable way by using a graph, I think it's quite powerful. Yeah, so I hope this was useful. If you do find it useful, please subscribe, and thanks for watching. Cheers, Andrew Jackson, AJ Design Studio. Bye.